Hello, I'm Roman. Welcome back to a series of the videos of building the convolutional neural networks from scratch in a Golang. And this video is going to be the last one actually in this series, and I want to share a few things before I actually can close the series because, I actually fulfilled all of the things that I wanted for studying the convolutional neural networks. I mean, I made a small break in the recording of the videos. There are a couple of reasons to this. One of them is actually described in the video on my main channel. There should be a link on top of this here right now. You can check. But basically, in between, I still did some coding for this problem. In the last video, I managed to run the few architectures on the convolutional neural network, one with the one convolution layer and another one with the second. In meanwhile, I actually did a couple of things. So the first one is actually I implemented the MaxPooling layer. So if you remember, I started it before, and that was the time before I kind of decided to start from the scratch again and implement something. So the MaxPooling layer had few options, and it's implemented in the same way as the convolution. So I have some things like the input shape and the output shape that I can reuse, and I will show later how I use in the output shape. There are some stuff that produce the output of the MaxPooling during the training and the prediction, but we don't need to actually store it. So we have the initialization. The main idea of the MaxPooling layer is that it reduces the output based on the pool size. So in all of the places right now, I'm using the size of the 2. Actually, it's actually a mistake. It should be like this. It should be like this, but yeah, we have the input shape and the output we define as, like for example, with the pool size 2, we'll have 4 times less data. And yeah, there is a function that loads from the params that's basically used to load the model from the file. And we have the forward method. Same stuff, so we going through all of the input samples because like this code is based on the neural networks on the Scratch series, and the idea that the forward method takes array of the samples, not just one sample per time, so it's actually kind of batch processing. And we're doing some stuff, we're declaring the output, and you can see right now we're using actually the output shape total size function, which computes the size of the one-dimensional row where we'll store all of the data. Basically, it's just multiplication of this. And then this is the code for one sample of the MaxPooling. The idea that we need to understand the target indexes for the MaxPooling and then create a range. Like we take in, for example, for one element in the output, we take in 4 elements from the input data. So this is where we're using the slice of it, and we just take in the maximum value, which corresponds to, MaxPooling as the name. We could implement the average pooling. It's used in the convolutional neural networks as well, but I just went with this one. So the only difference that instead of the maximum value, we'll use the average value. And then the question is how to store the output sample. This is the one-dimensional. What's happening today? This is the one-dimensional array that corresponds to the output results for the specific sample during the forward pass. And we just calculating the index in a way that we convert kind of a 3-dimensional array logically into one-dimensional. And that's it. Then we store it here. And for the backward pass, it's actually kind of reversed. So we have the things that come as the d value. So it's the derivatives with respect to the input from the previous layer during the forward pass, which is the next layer in the network. And the only difference that we're actually doing all the same things, The only difference that we calculating the mask for the slice based on the maximum value, and the idea that we only propagate the d value to the next one only for the element that had the maximum value. Everything else will have the 0. So for example, from 4 elements, so for example, we had the slice, I don't know, 1, 2, 5, 9, something like this. So the 9 is the maximum value, which means that we'll have the mask like this for derivatives, and we will propagate only, and we'll only propagate the derivative values from the previous one corresponding to this one. Maybe I'm going actually too much into the details, but that's not the case. So like the idea of the MaxPooling is we taking the input value and we shrinking it, with downgrading it like in the size. So that's the MaxPooling, and it's actually used in few architectures. I will show you later. The next one is, you can see it here, and I did the same in the convolution. I mean, just a disclaimer that these implementations never tend to, to pretend that it's super performant and that's it. But even for testing the architecture, that actually what it took me most of the time in between videos, just messing around with the training parameters and see the output. But one of the cool things about the convolution and why it's actually very good for the GPU training is because you can, like if you have multiple kernels and the input data, you can run all of the computations in parallel and then kind of collect all the results. I do not use the GPU for this. Maybe that could be an interesting video series to do. But here I just run computation for every input sample in different goroutine. And yeah, then we just do all of the things. The only thing that I will fix before pushing the code, actually fully stop working on this series, is this part. In the MaxPooling, it's done better. So I'm collecting all of the results into the temporary array and then setting it outside of the whole array. But anyway, so the idea that I can run things in a parallel, which speeds up like a lot the training, especially for the big convolutional network that I try to do. Same for the backward pass. So it gives you more or less of the performance, at least for this simple task. Yeah, and as I said before, I spent most of the time actually messing with different architectures. Let me find them in this one. Right. And I refactor a little bit this code so I can train and store multiple architectures. So this is the dense model that we created during the Neural Networks from the Scratch series. It's fully based only on the dense layer and the ReLU activation, apart from the last one, the softmax activation, because we need it to kind of convert it to the output values. Then I had the same architecture, the only difference that I added the convolution layer on top of this. And here you can see an example of using the output shape. So I can pass it into, for example, the dense layer. Like in the Python, if you will search for examples of the convolutional networks, you will see that there is a convolution, MaxPooling, convolution, etc. And then there is a flatten layer, which does the same thing, because convolution layer stores everything in a multi-dimensional array, and the dense layer works with one-dimensional array. So they need to use the flatten to convert it. The way I implemented it here, I store everything like regarding one sample always as one-dimensional array, and I'm using this input-output shape to know how I can interpret this block of the memory as, for example, 2D, 3D, or even 4-dimensional array like we have in for the kernels. control. So for the kernels in the convolution. So we have the kernel shape. You can see that it has depth of the convolution layer, input depths, height and width, basically 4-dimensional array. That's the first. The second architecture I tried is to take the convolution and take the MaxPooling layer, and then we're using the MaxPooling layer results as the input for the dense layer. That's another one. Then I played around with the 2-layer convolution that was done in the previous series. It was like a little bit surprising for me. That part actually worked without any issues. So, and this is, I found, like, but when I played with this architecture, I tried to change different optimizers and different parameters, but the results were more or less the same as with the dense layer architecture fully. So probably I didn't train enough as I see right now, but yeah, so I find this, this is the Python code, and actually you can see this is the flatten that I taught before. So we have the so they actually have the 3 2D convolutions and 2 MaxPooling, and then they have like 4 dense layers, so that's much bigger. I replicated it mostly apart from using so I just used 2 times combination of the convolution and the MaxPooling layer, then got the same several dense layers with the relo activation and the softmax in the end. And I trained all of this. So if you can take a look at the main, well, I have the train and I have load the models. So those are all of the models that I trained before. And right now you can see that I can evaluate them against validation data and actually see the results. So that's what we're going to do. Well, actually I ran it before. The sad thing, well, okay, before we can actually go into this, if I check this link, it's shown that they train for like 500 epochs, but they're using TensorFlow, which is way more optimized for long training. Plus, first, I don't have a GPU where I can train. The second one is, well, my implementation is far away from being performant. So for me, like, I train for 30 epochs and it take quite significant time. So I didn't train it for 500 epochs. That probably will give me much better results. But the thing is that all of these architectures gave me more or less the same results. For example, this is the accuracy 87% of the dense model. And if you go next, the bigger model actually has 85, which is even less. 82 was the 2 layers of the convolutions. 85 with 1 layer and 1 convolutional layer and 1 MaxPooling. So it feels like the MaxPooling actually adds more. And 87 with just 1 convolutional layer. So the thing is that, and if you take a look at the train, I think the problem, like, I don't think I have a big mistake somewhere in the implementation of the convolution and the MaxPooling. They actually look very valid. Most likely the problem that I do not train enough, or I train with the wrong optimizer or with the wrong parameters. The problem that, well, that's actually the problem. I mean, the idea of the series was to actually understand how the convolution works, how the convolutional neural network works in the model, in the layer itself, and implement it really from the scratch. So, especially in the beginning, I was very confused by the input and the outputs of the convolution, because I actually thought that I understand how it works. Turns out, not fully. So the idea of the series was to actually build it, and I succeeded in this. To be honest, it was a little bit boring for me to, just trying to guess the right parameters and improve the loss and the accuracy. I remember from the book and from the FastAI course that I just have to spend some time with this, and eventually I will get a grasp and understanding of how each parameter contributes to the loss and the accuracy. And that's actually true, because when I started to train the CNN stuff, CNN versions of the model, I had like 70% of the accuracy, so I got to the dense layer accuracy level. Maybe like after this, I will actually spend some time trying to train for longer, or do not use, for example, Adam Optimizer, or try again to change the parameters, and definitely will train for longer, for more epochs, not 30, but I don't know, maybe 100, so I can get way more accuracy, at least upper 90% than I have, for example, for the dense layer. But I don't think it's worth, posting it as the live coding videos, because it will be just, oh, okay, so with this set of the parameters, loss is getting better, or maybe it's not decreasing that fast, and okay, let's change this, I don't know, decay or something else in the optimizer, and that's it. I want to create a follow-up video on the main channel, kind of highlighting, kind of explaining the convolution and highlighting the problems and the solutions when you will try to implement it like from the scratch, not by just using the TensorFlow PyTorch implementation of the layers and just combine them, because you can see like basically this is, well, that's the whole implementation of the model. Then you just need to write a couple of lines of the code to load the model, load the data. Then you need a couple of lines of code to start model training, all of this provided by all of the popular neural network tools, by deep learning tools. So it's not really helps to understand how the convolution really works under the hood. So I want to create a follow-up video, and I will publish it on the main channel, not this one. And I will think what's going to be next for actually this channel and what's going to be the next series. Most likely, as I wrote in the Discord server, it's going to be something backend distributed systems related. I'm just thinking of an interesting task to solve that will require something like this. I always can go with some CRUD API, but that's the fallback plan. I will just go with some CRUD API for something boring, but at least I will practice the backend stuff. It's still going to be the Golang. Apparently, I enjoy this language and want to dive. And again, as I told in the video that I mentioned before, I kind of shifting into the backend right now very quickly. Not sure if it's the permanent change or the temporary change. We'll see. But that's actually the interesting. But yeah, for the convolutions, it was actually very interesting to trying to solve it. The main, I will talk about this deeper in the follow-up video, but the main problem, like the main mistake that I made, is actually I thought that I will implement it easily and very quickly. I actually thought that it will take up to 10 videos for me, because I implemented, the code is based on the previous series and I more or less understand how it works. Turns out that I had many confusions about the convolution, and also, it's not that much material online you can find if you want to implement it from the scratch. Well, especially if you want to do it not in a Python, it's just impossible to write some good material. I found a few articles. Some of them were like very deeply into the convolution, explaining all of the possible edge cases, because, for example, my convolutional layer that I built, it doesn't support, for example, the stride or some other parameters that you can configure. so it's less flexible in that case. Some of the articles had mistakes, so I wasn't sure like how you can even use it. I found a very good video that I used in the previous videos that explained the convolution very good. The only thing that, again, it uses Python as the language to implement, and Python hides many things with NumPy. So hopefully my video will fill this gap because Golang is actually very verbose language, and I mean, if you could write it in a Go, this code more or less can be easily transferred to, for example, C. With some additions, of course, mostly about the memory management and stuff, but like the steps probably will be the same, which is not the case if you will try to move implementation from just reading the Python code and trying to implement it in a C. That would be very different. Okay, that's it for today. I'm closing this series. Thank you for watching, and I see you in the next one. Bye bye.